balance section, we have seen that the critical neutral axis is denoted as XC, and the equation for that is sigma CBC upon sigma ST by M is equal to XC upon D minus XC. Okay. And for an under reinforced section, the neutral axis is calculated by taking moment of area of compression side and tension side. Okay, this one. So this will be B into X into X by 2 is equal to M into AST into D minus X. For an over reinforced section also, we will use this equation. So this was all about your balanced under reinforced and over reinforced section. So we have seen the diagram, the stress diagram, how the neutral axis changes, and we have also seen the formulae. So when we're talking about balanced, we talk about the critical neutral axis. Okay. So please make a note of it. Then we will proceed to moment of resistance. So let us move on to the next topic, that is moment of resistance. Okay, so first of all, what do you mean by moment of resistance? If anyone knows, they can write, or we can see is the capacity of the section, how much the moment the section can resist. So basically it shows the capacity of the section. So it is a very important parameter of any section when we are designing the section. So whenever we are designing the section, we should know what is the capacity, moment carrying capacity of that section. So that is the reason we find out the moment of resistance. I hope this is clear to everyone. So let us see now. So please write simultaneously whenever I'm showing you on the sheet. So moment of resistance, it is denoted by MR, as you can see on the sheet. So basically it is a couple formed by the total tensile force T and the total compressive force C. Okay, so the total compressive force, now here you can see the equivalent stress diagram. This is the equivalent stress diagram. So in this, please mute yourself. So here you can see that. So this is the total compressive force C in the compression zone, and the total tensile force, it is right at the CG of the steel, that is at the center of the steel. So this is your total tensile force. So now this total compressive force will act, since this is a triangular portion, so this will act at a distance of 1/3 from the higher side. I hope this is clear. So since this is a triangular portion, so the total force will act at a distance of 1/3 from the higher side. So this is x by 3. And this total tensile force is right at the center of the reinforcement. So now the distance between these two forces, that is your compressive force C and the total tensile force T, is called as the lever arm, which is denoted by Z. So can you see here in the sheet that Z is called as the lever arm, or the distance between the total compressive force C and total tensile force T. And this distance is given by, we know that this is D from the top compression fiber to the center of the reinforcement is D. So this distance will become how much? This we know it is x by 3. So this will become D minus x by 3. So I hope this is clear to everyone. The lever arm Z is given by D minus x by 3. And now that is total compressive force into Z, that is lever arm, or it is given as T into Z, that is total tensile force into lever arm. So when we talk about C into Z, C we know that it is B into X into sigma CBC by 2. We have already seen this. Okay. And Z is nothing but D minus X by 3. Correct? So this MR becomes B into X into sigma CBC by 2 into D minus X by 3. Okay. Similarly, when we talk about MR is equal to T into Z, T we already know it is stress into area, sigma ST into ST, and Z here we can see it is D minus X by 3. So sigma or T into Z. So now we have derived the equation for moment of resistance. So now we will talk about the moment of resistance for a balanced section, under and over reinforced. So for a balanced section, remember the moment of resistance is given by either C into Z or T into Z. Since it's a balanced section, both will give the same value to us. So we can use MR is equal to C into Z, or we can use T into Z. So you just have to remember, make a note of it. And when we talk about an under reinforced section, remember MR is calculated by using the equation T into Z. Okay, why? Because here steel fails first. So that means steel reaches its permissible values first. So that is the reason for an under reinforced section, moment of resistance is calculated always by using T into Z. Okay, so make a note of this. And finally, for an over reinforced section, MR is given by hello, am I audible now? Okay, okay. Okay, so we have seen what is moment of resistance, what is the equation for moment of resistance, right? We have also seen for a balance section how to use the moment of resistance. For an under-reinforced section, MR is given by T into Z, and for an over-reinforced, it is MR is equal to C into Z. So finally, we have finished the derivation of all the equations for the numericals to be solved. So now we can actually start with the numericals. So please make a note of this. So you have already noted down. We can start with the numerical. So shall we start with the numerical, or you're making a note of it? Okay. So please write it down. So as we have already seen in the first lecture, that I have told you that there are total 3 types of problems. So this is the first chapter we are doing, that is singly reinforced section. So in this we have 3 types of problems. First is to find out the moment of resistance. The second type is to find out the stresses in the section, and the third type is to design the section. Okay. So we have, so I think we can start with the numerical now. So what I'll do is I'll dictate the numerical to you. So please write down the question, and then we'll start with the solution. So are you ready for the first question? Please write yes in the chat box. Okay, fine. So let's start with the first numerical of this semester. So note down question number 1. Determine first the position of the neutral axis. Second, lever arm. Third, moment of resistance. And fourth, percentage of steel for a rectangular section of width b mm and effective depth d mm.
Sir, can you repeat?
Yes, I'll repeat. I'll start from the beginning. Determine first the position of the neutral axis, comma, second, lever arm, third, moment of resistance, and fourth, percentage of steel. Okay, I'm going slowly. And fourth, percentage of steel for a rectangular section of width b mm. Okay, so width is b. That means in terms of b only you have to find out. B as in Bombay, I'm talking about width b mm, and effective depth d mm. D as in delta. Okay. Take sigma CBC equal to 5 Newton per mm square. Take sigma CBC equal to 5 Newton per mm square. Sigma ST equal to 140 Newton per mm square. Sigma ST equal to 140 Newton per mm square. Modular ratio M is equal to 18.66. modular ratio M is equal to 18.66. I hope, so that is the question. I hope everyone has noted down the question. So basically you have to find out four things. First is the position of the neutral axis. The second is the lever arm. The third is the moment of resistance. And the fourth one is the percentage of steel. And the section dimensions are B and D. And the stresses and modular ratios. Is that done? The question is noted down. So now let us begin with the solution. So first thing, we will write the given data. Okay. So first, let us write the given data. So first write, as you can see in the screen, write given. So stresses are given to us, that is sigma CBC is given. Yes, the second is lever arm, Z. So the given data, you can see sigma CBC is 5, sigma ST is 140, and M is equal to 18.66, and also B comma D are given to you. So always write in this format which I've shown. First write whatever is given, then write what you have to find out, and then finally the solution. So now to find, four parameters are given, correct? So first we'll find out the neutral axis, and then Z, there is a lever arm, and the third is moment of resistance, and let us say percentage of steel, let us say it as PT. Okay. So now first step, we'll find out the neutral axis. So since on the basis of the given data, we know that the formula for the neutral axis is given by sigma CBC upon sigma ST by M, because since the stresses are given to you and the section dimensions are given to you and modular ratio, so we are going to use this formula. Sigma CBC upon sigma ST by M is equal to XC upon D minus XC. So just substitute the values and give me the value of the neutral axis. Anyone has got the value, they can write in the chat box. Anyone? .4 D. Absolutely correct. Anyone else? So let us see. One student has already got the answer. That is Zainab. So now let us see. Sigma CBC is 5, which is given to us. Correct. Sigma ST is 140 upon M is given. So D, in terms of D, we will get the value of X because D is not given. So if you calculate this, you will get XC is equal to 0.4 D. Is that clear, everyone? Now let us go for the second unknown, that is lever arm. So what is the equation of lever arm? Z is given by D minus XC by 3. Am I correct? So let us see. D minus XC by 3. XC is nothing but in terms of D. Now what is the value of Z? Anyone? Write in the chat box. I hope the others are getting the value. 0.867 D. 0.87 D. Correct, correct. Okay. So you can make that into 2 digits also, no problem. Or you can keep it in 3 digits also. So now we got the 2 parameters. Now let us go for the third unknown, that is MR. So MR is given by C into Z. Okay. So C is nothing but B into XC into sigma CBC by 2. into z is d minus xc by 3. So you have already got the value of z, so you can directly substitute the value of z. Okay. So substitute the value and give me the value of mr, anyone? If anyone has got the value of mr. Yes, am I audible? I think by this time we should have got the answer. Yes, Saurabhji. We have assumed it as a balance section to find mr. Since you don't know the AST, so we are going to use mr is equal to c into z. Is that clear? Okay, 0.87 BD square. Correct. Okay. So I hope you are with your calcs, so you'll get the answers. So this is just the beginning. So in due course of time, you have to be a bit quick because you know that it's a huge syllabus, and since it's a design subject, so it's very difficult to complete the syllabus. So we have to be quick. So now let us go for the last unknown, that is PT. So if anyone has got the value of PT also, they can write. So let me do it for you. To find PT, that is percentage of steel. If anyone has done it. So now to find out the percentage of steel, what we need to find out before that, anyone? First, we should know the amount of steel, right? Then only we can find out the percentage of steel. So how are we going to find out the amount of steel? Absolutely correct, Munir. So how are we going to find out the steel? Which formula we are going to use? So we have already seen the different formulas and the derivation of that also. So anyone? So now for this, we are going to make the use of the second formula. That is, we will equate C equal to T. If you have remembered, so by equating C equal to T, we get B into X into sigma CBC by 2 is equal to sigma ST into AST. Is that fine? So now substitute the values and find out AST. Anyone find out the value of AST? Okay, so we know that this is B. So we have only 10 minutes remaining. I hope everyone has written their name properly in the format. Now please don't write it again. I'm just confirming. So now let us find out the answer for this. So XC is nothing but 0.4D, correct? B into XC sigma CBC by 2. What is sigma 5 by 2 is nothing but 2.5. Okay, so AST upon sigma ST. So therefore, what is AST? 7.14 into 10 raised to minus 3. Are you sure, Drashti? Okay. So let us keep it as it is. This is nothing but BD upon 140. Am I correct? Mm square. Is it visible? Is this fine? So now we will find out percentage of steel, that is PT. Percentage of steel is given by anyone. Percentage of steel is given by AST upon BD into 100. Absolutely correct, Aditya. 1 upon 140 BD. So now we know that percentage of steel is given by the total amount of steel upon the cross section area into 100. Okay. So remember this, we are taking the effective depth in design. So AST upon BD into 100 was what is AST is nothing but B into D upon 140, and this is B into D into 100. This BD gone. What is 100 upon 140? Give me the value now. 0.74714. Correct. 0.714 percentage. So this is the percentage. Is this clear, everyone? So we got all the unknowns which is asked in the question. So first we got the neutral axis, then the lever arm, then the moment of resistance, then the percentage of steel. So this was a very basic problem which I have shown you just to make you aware how to use the formulas. Okay, so such questions are not going to be asked in the examination. This is a very basic problem, so that to get for you to understand how are we going to proceed. Percentage of steel. Okay, if you want to find out the percentage of anything, that is the quantity of that upon the total cross section into 100. How do you find out your percentage of marks? So marks obtained upon gross total into 100. Is that correct, Danish? So similarly, AST, what we have found out upon the total cross section of the section, that is B into D. So remember, in design, we always take the effective depth to find out the percentage of steel. We don't take the overall depth into 100. So AST is nothing but BD upon 140. So this BD cancel. So this is the value of PT. I hope that is clear, Danish. Anyone else, if you have any doubt, you can ask right now. And please make a note of this. So we have 5 more minutes left. So shall we go for a next problem? Please write in the chat box. Okay, fine. So let us move to the next problem. Before that, I'll just, so this was just a basic, so that you understand how are we going to use the formulas. So now, before starting the problem, I'll just give you the steps. So please write down the steps. So in the next lecture, we will start with the problem. So write down procedure to find out MR, that is moment of resistance of a given section. Write down the procedure, write down this heading, procedure to find out the MR. So write down first step, find critical neutral axis XC by using the equation sigma CBC upon sigma ST by M. equal to x upon d minus xc. So this is the first step. Second step, find the actual neutral axis x by
The first step
is find critical neutral axis xc. Formula you already know. Sigma cbc upon sigma st by m is equal to xc upon d minus xc. So whenever you are finding out the critical neutral axis, you will always use this formula. So second step, find actual neutral axis x. So which is the equation for this? We have already discussed. By b into x by 2 is equal to m into ast into d minus x. Okay. So if you know, then no need to write that formula. So just write down, find actual neutral axis x. The third step is very important step. Compare x and xc. Third step is compare x and xc. That means compare actual neutral axis and critical neutral axis. That is the third step. So in the same step, write if x is less than xc. That means if actual neutral axis is less than critical neutral axis, then the section is under reinforced. And if x is greater than xc, then the section is over reinforced. So that is your third step. I hope this is clear to everyone. If x is less than xc, then the section is under reinforced. And if x is greater than xc, the section is over reinforced. Then the fourth step, the last step is find MR. The fourth step is find MR. So MR equation you already know. MR is equal to T into Z if it is under reinforced, and MR is equal to C into Z if it is over reinforced. So I've just explained you the procedure. So make a note of it. So whenever we solve the problem to find out the MR, you are going to follow this procedure. Is that clear, everyone? Very simple procedure. First, you have to find out the critical neutral axis. Then the second is to find out the actual neutral axis. And then you have to compare करो और find out which section is that. और last में इसका capacity, that is MR निकालो. Is that clear? I hope everyone has noted down. So in the next lecture, we are going to start with the numericals on MR, that is to find out the moment of resistance. Is that clear? So basically in today's session, we have seen the derivation of all the formulas, the conceptual part, then balanced under reinforced and over reinforced section. And then we have taken one small problem on how to use everything, the formulas. And we have also seen the procedure to find out the MR. So in the next lecture, we are going to start with the first type. And then please be ready from the next session. We have to be a little quick and solve the problem.